All right, good morning, y'all. Okay, so a couple of things. Make sure you grab your warm up. You should work on it for the first 10 minutes. If those 10 minutes have not already lapsed, then somebody pause my video and wait, until y'all have a little bit of time to work on that. But that is not part of my video, so we will make sure we cover that tomorrow as well. Okay, so I've kind of gone back and forth about what to do today when I'm not there. So, we talked last week a little bit about flipping our classroom, and we're going to kind of do that today. It's just that you'll have some time in class to work on what we're actually going to talk about tomorrow. But the first thing I need to do, make sure your phones are put away. Obviously, you don't need that distraction during class today. Make sure you're on your best behavior. If you weren't here Friday, I think Andy, I think that's only you. Then what we did Friday should be on the board. If it's not, then I will leave some extra copies of the notes with the sub anyway. But I think I put everything on the board for Friday. But anyway, on Friday, so we did do test corrections, so we did not get through all of our notes. So I'm going to start by finishing up test 5, lesson 2 on connecting f of x, f prime of x, and f double prime of x. So we're going to finish up that last part. And I'm going to go through that. It'll seem relatively quick, but remember, we've done pretty much everything there is to do. So the end of those notes were pretty much just extra examples. I think we finished. My memory is not the best on what we did Friday, y'all. Sorry. But I do think we finished out example 2, and we are on example 3. So I will go through example 3, 3 and 4 with y'all, and then I'm just going to post example 5 in your notes in Canvas so that y'all can just kind of fill that in at your convenience. And then after that, we're going to move into what you'll be doing for tomorrow. So let me get through these notes, and then I'll kind of explain a little bit of that as well. So jumping right back into example number 3 from connecting. Okay, so for each of the following functions, find all relative extrema and points of inflection and justify your answers. Okay, so remember, whenever we're talking about any of these, we need our derivatives, both the first and the second. Okay, so I'm going to go ahead and start by finding the first derivative of f of x, which is going to be 2x plus 3. All right, and remember, we want to take that and set it equal to 0 and solve. And that's what's going to go on our sign analysis. Okay, it is a 0, so I'm going to put a solid dot there, and let's just sign analysis that. So if I plug in a really, really big negative number, obviously a negative times 2 plus 3 is still going to be negative. Odd dots change, and this is our f prime of x. So then remember, f of x would be going as such. Okay, and then our f double prime, so this is f prime of x, 2x plus 3, so f double prime of x is going to be 2. Okay, so disclaimer here, y'all. I don't know if you saw it whenever I started my video. It is literally 12:30 a.m. Monday morning, and y'all know I don't function well on no sleep, so there's no telling how many mistakes I'm liable to make in this video. I do apologize in advance for that, so I will try to catch them if I make them as I go. But it's just been a long weekend, and this is when I had a chance to sit down and get this done. So, bear with me. All right. So f double prime of x is equal to 2. All right. So then once we know this, remember, for all relative extrema up here, okay, our relative extrema are going to be where f prime of x changes signs, and our points of inflection are going to be where f double prime of x changes signs. Okay, so let's see what we know. So we've got our sign analysis here, so we can go ahead and say that we have a relative min at x equals negative 3 over 2 because f prime of x changes from negative to positive. Okay. All right, and then likewise, we can go ahead and say that f of x has no relative max because f prime of x never changes from positive to negative. Okay. All right, so that's our extrema. And then to talk about our points of inflection, that's going to be something where our double prime, our second derivative, changes signs. And that's obviously not going to happen with that constant. So we can go right back in there and say that f of x has no points of inflection. Y'all can abbreviate as long as you know what you're talking about. Just remember not to do so on the actual AP exam. As f prime of, because f prime of x or f double prime of x never changes signs. Okay. All right, so let's look at letter B. Okay, so let's take the first derivative. So first derivative is going to give me 6x minus 3x squared. And then I'm going to go ahead and jump right over here and go ahead and do the second derivative real quick. So g double prime of x is going to give me 6 minus 6x. Okay. All right, so let's see what we know here. We're doing g double prime, or g prime, sorry, set that equal to 0 so I can factor out my 3x. Which gives me 0 and 2 for my sign analysis. Those are both zeros. They both happen once, and this is g prime of x. All right, so they pick a really, really big negative number, right? So if I pick a really, really big negative number, this outside is going to be negative. 2 minus a negative is going to be 2 plus. A negative and a positive is going to be a negative. Odd dots change. Odd dots change. So that means our g of x will be going down, up, down. All right, so then we can go ahead and do our extrema. So g of x has a relative max at x equals 2 because g prime of x changes from positive to negative. All right, and then g of x has a relative min at x equals 0 because it changes from negative to positive. Okay. All right, so now we've got the second derivative over here. So let's go ahead, because it's not a constant. All right, so we're going to go ahead and we're going to factor this. So I'm going to factor out my 6. Okay, set those equal to 0. So nothing here. So this is just going to be 1. So on my sign analysis here, we've got 1 in the middle. Okay, if we plug in a really, really big negative number, that's going to be positive times a positive 6 is going to be positive. Odd dots change. So this is g double prime of x, which means g prime of x is going up, going down. Don't really need that. It's just a habit, sorry. Okay. All right, so then now we can say, because it does change signs, we can say that g of x has a point of inflection at x equals 1 because g double prime of x changes signs. Okay? All right, letter C. Okay, let's jump right to our derivative. So the derivative of h, so h prime of x, is going to be 8x cubed minus 12x squared. All right, so let's factor out our GCF here, which is going to be 4x squared. Sorry, 4x squared. That's going to give me 2x minus 3. And we want that equal to 0. I don't have any whiteout at home, y'all, so you just have to pretend that this little blob's not there. It's a habit of writing that equal sign. Okay, so then our zeros here are going to be 0 and 3/2. 3/2. 3/2. All right, so now let's do our sign analysis with that. 0 and 3/2. Both of them, 0 appears twice. 3/2 appears once, so this is h prime of x. All right, so pick our really, really big negative number. So if you square a negative number, we're a positive outside. Negative number inside is going to be a negative. So negative, even dots stay the same, odd dots change. So then we know h of x would be as such. All right, so I could go ahead and make my conclusions. I'm just going to go ahead and do my second derivative. So h double prime of x is going to equal 24x squared minus 24x. Okay, you can factor out your 24x here, which is going to leave me with x minus 1. So then 0 and 1 are our sign analysis numbers here, and this is h double prime of x. Okay, so that gives me a really, really big negative number, gives me a negative and a positive, and a negative times a positive. Whoa, hold on. Negative. That would be a negative times a negative. Okay, negative times a negative, my bad. So negative times a negative is going to give me a positive. We are one of each here. So odd dots change, odd dots change. So now we can make all of our conclusions over here on the right. Okay, so the first one, we know h of x has a relative min at x equals 3/2 because h prime of x changes from negative to positive. Okay, from negative to positive. But then we can also say that h of x does not have a relative max because h prime of x never changes from positive to negative. Okay, and then the last one we have here is our point of inflection. So we can say, let's see, it changes from positive to negative. So there's 1 at 0, and from negative to positive, so there's 1 at 1. So h of x has a point of inflection at x equals 0 and x equals 1 because h double prime of x changes signs. All right. So that is example 3. All right, and then we're going to walk through example 4. And after example 4, like I said, what I'm going to do is I'm going to jump to the next thing for you to do for today. And then I'll post your notes at the end here of example 5 and is it 5 and 6? Nope, just 5. Okay. All right. So last example down here that we're going to work on. All right. Example 4 is talking about concavity. Okay. So for each of the following, determine where f of x is concave up and justify your answer. So notice they gave us the derivatives here. So we're going to take the second derivative of each of these. Okay, so for the first one, so f double prime of x is going to equal 3x squared minus 6x. All right, so let's just keep rolling. Setting that equal to 0, factor out our 3x. So our zeros are 0 and 2. Both of those are singles. Okay, so that's f double prime. So then we know f prime is doing something on here. Okay, so plug in a really, really big negative number. That's going to make the outside negative. A negative number here is going to make the inside negative, and a negative is going to be a positive. Odd dots change, odd dots change. So we will be going up, down, up. All right, so all we're asking about is concavity. So we know it is concave up whenever it is positive, greater than 0. Okay, so we can say f of x is concave up on the interval negative infinity to 0, union 2 to infinity, because f double prime of x is greater than 0. Okay. All right, so for letter B, just a little different here because we do have this. Remember, we're going to rewrite this as x squared plus 1 to the 1/2 power. It just makes it a little bit easier whenever we're differentiating. Okay, so when we find the second derivative here, it's going to be bring the 1/2 down front. X squared plus 1, and then we got to chain rule this. Okay, so your 2's are going to cancel. So we end up with x over the square root of x squared plus 1. Okay, we can have a 0 on the top here. X could just be 0. Nothing's going to make this bottom 0 because remember, we're squaring. If you add that 1, it's going to end up being a positive number. Okay, so on our sign analysis, the only thing we are going to put is 0 because this one right here can be 0. That's on the top can be 0. All right, so this is our f double prime. So if we pick a really, really big negative number, that's going to be a negative on top, a negative squared, plus 1 is a positive, and a positive is a negative. I'm going to pick a positive because of our fractional exponent. I'm not going to try to do the dot thing. So I'm going to pick a positive. Positive over a positive is going to be a positive. Okay, so we can say f of x is concave up from 0 to infinity because f double prime of x is greater than 0. Okay, so that was example 3 and 4 from your notes from Friday. Okay, so we're going to move into today's assignments, and then after that, I will put the second page, or the last page, example 5. I'll slide my note template under here, and y'all can just pause that on the screen or whatnot at the end of the video today if you need to. Okay. So going back and forth about how we're going to do class. We've already talked about that. But here's what I'm going to try. Okay. So your assignment right now, if I can get the test 5 lesson 3 note template passed out. Okay. It should look like this. Okay. It's got all these all these blank boxes. Okay, so pause my video, or somebody can pass this out for me. But this is what you are going to work on in class right now. Okay, and what I'm going to do with this, because y'all, is an extension of what we have literally done for the last 2 lessons in Test 5. It is another extension of that. So what I have done is I have actually pre-typed these in on mine. And basically what you're doing here is you are going to be looking at different graphs over here. So there's this one, and there's this one. Okay, I don't think, no, they're not, okay. And you're going to look at those and you are going to draw your conclusions. Now, here's the thing. There are several conclusions that you can draw immediately that are the common things that we know from this graph based on, this is the graph of f of x. So pay attention there. That one's f of x. This one's f prime of x, and this one's f double prime of x. Okay, so make sure you understand that, because it makes a difference what all we're necessarily going to say. Okay, but I'm going to tell you that whenever I give you the answers to this tomorrow, I'm going to tell you how many are in each one, and you can write them. If you are a person that is super finicky about your notes, you might just want to write your answers on a separate sheet of paper and then transfer them over tomorrow whenever we confirm that you are correct. Or if it doesn't bother you at all, then write what you think, or write in pencil, or whatever makes it easier for you. But I do want you to actually, you can work together. You can move around if you need to work with a partner, but I do want you to evaluate these 3 problems and try to think about, using the chart that we have about, going up and down on f prime, and f double prime. What conclusions can you draw from this graph? Okay. And I'm going to talk about a couple on Test 5 Lesson 3 real quick in the first one, just to kind of give you an idea of what I'm looking for my answer there. Okay, so for instance, the things that we're talking about, the things that you want to be cognizant of as you fill these in. I'm just going to kind of put this up here at the top. Obviously, we want to think about increasing and decreasing. Okay, we want to think about max and mins. We want to think about concavity. Points of inflection. Okay. So those are the things that we want to think about whenever we're doing this. So looking at the graph, blah, blah, blah. All right. So I am going to give you I'm going to give you one of these that I don't think many of you will think of for the first one. But I'm going to go ahead and tell you right now how many facts I have, how many conclusions I have drawn in each one of these boxes. Okay. So for example number 1, the conclusion is about f prime of x based on the graph of f of x here. I have 11 total conclusions in this column here. Okay, and I'm going to give you one that I don't think many of you would think about, because it's not one of our major things that we have hit on in this topic, this test. Okay, and that is that we can go ahead and conclude that if you look over here at f of x has 1, 2, 3 extrema. Okay, and so your degree is always one more than that. Okay, so if we have 3 extrema, that means that f of x would have a degree of 4. Okay, so that would make this quartic. So that is one of the first things I'm just going to put up here for you. Okay, we know that f prime of x is cubic because f of X is quartic. Now that is one that, the reason I'll put that there is I don't think many of you would think about that to be one of our things. So we have not discussed that necessarily as repetitive as we have other things. Okay. All right. So again, there are 11 total conclusions about f prime of X based on this graph of f of X. Okay. And then over here, I have 4 total conclusions about f double prime of X based on what we know. Okay. So that's, again, you're going to work together here for the remainder of class between this and your worksheet on test 5 lesson 2. That's the 2 things that you're going to work on in class today for me. All right. So then the next one, okay, again, this is the graph of f prime. They want you to make conclusions about f and f double prime. All right. So I will go ahead and tell you that for the left side, for the f prime of X, I have 8 total conclusions. And again, on that one, you can include the same type that I did for number 1 on the last one. That's one of my statements for this one. And then for our conclusions about f double prime of X over here, I have 7 conclusions I can make. Okay, based on this graph. All right, and then the last one of these that you're going to be looking at, I have... I've lost my note key. There it is. Okay. I have 3, 4, 5, 6. I think it's 7. I'm pretty sure it's still 7 for this one. Pretty sure. It might be 6, but I want to say it's 7. And then over here I have 4. And remember, this is the graph of f double primes, and they're asking you about f prime and f. Okay? All right, and then once you get some of those written down, as many as you can, again, y'all, you work together. Use the knowledge from each other on what you can conclude about each one of these graphs. All right, and then after that, you are going to work on the calculator active questions here for the remainder of class as well. Okay, so pretty short and pretty sweet, the video part for me today. Because you are working on flipping these notes for me for tomorrow. So then tomorrow when we come in, I'm just going to kind of unveil the right conclusions that we should have. And we'll talk about any that I don't have. That you don't have that I may have. Or if you have some different ones, why they might be incorrect or anything of the like. Okay. And then you are also going to work on example 1 through 6, okay, of the calculator active questions on this topic, okay? All right, so that is what you're working on right now. And then after this, your homework is from Friday. Okay, with test 5 lesson 2 worksheet, okay? And again, y'all, this is all that wording, okay? That some numbers in there, but it's a lot of wording on that. So that is from test 5 lesson 2 from Friday. So your homework tonight is that worksheet. And then your classwork for me for the remainder of class today is to fill in the best you can to flip these notes for us so that they're already done for us tomorrow. And then if you do finish this or get as far as you can get on this, then you can go ahead and start working on test 5 lesson 2. All right. So then remember, your test is on Thursday, I believe, tutoring on Wednesday for y'all. I need to make sure that's right. Hang on a second, y'all. Well, I thought I had my pacing guide with me, but maybe I don't have our pacing guide to look. But anyway, I'm pretty sure that your test is on Thursday, which means that I will tutor Wednesday. So we'll have Tuesday to finish up these notes. We'll have Wednesday for review, and then your test will be on Thursday. Yeah. Okay. All right. So we're good there. Okay. So you're working on this. After this, you're going to work on test 5 lesson 2's worksheet. I am going to slide the finished notes from the last page of notes from Friday up under here. And I'm just going to, what you're going to want to do is pause this video. Okay. Because I'm not going to leave it up here for a long period of time. Just because that's pointless for me. And it's 12:58 in the morning, so I'm not just going to leave it running. Okay, so you're going to want to pause this video, and I will also put these in Canvas ultimately, but this is just the back page of yesterday or Friday's notes, okay, where we talk about determine whether it's concave up or concave down. Truthfully, example 5A, y'all will be fine about. The only thing is that is the quotient rule there. And then on 5B, you do have to do the chain rule with that second one. Okay, so 2 cosine x plus the derivative of cosine is negative sine. And then because of the 2x, we've got to put a 2 down there as well. And I'll just go ahead and speak on this one real quick. This right here, once you get to here, we did use a trig identity on sine 2x, 2 sine x, cosine x. To be honest, y'all, there's not a whole bunch of those that are expected for you to remember. The basic ones that we talked about earlier this year are expected, but this was kind of a stretch for you to remember that off, just without us discussing it prior to. But we did use an identity there that turned sine 2x into 2 sine x cosine x, which is where I got this step right here from here to here. Okay, I'll slide up a little bit. Talk to you about what I did down here. Okay, so outside was equal to 0. Then I had to solve sine for 1/2. Remember that happens in 2 quadrants, so that gave me the pi on 6 and the 5 pi on 6. And so when I put all of these values on my sine analysis, right, everything's just written out here. And it's kind of difficult when we're doing trig functions and like radian measurements, so I like to use pi. I'm just going to pick pi and I'm going to plug pi in. So you're going to see down here, like I did the cosine of pi. So I went back up to here, right? I did the cosine of pi and 1 minus 2 sine of pi. Okay, cosine of pi is our -1, so that's a negative value. And then the sine of pi is 0. And so 1 minus 0 is going to be 1, which is positive. So that gave me a negative. So once I know that's negative and I can do my odd dots change, it's going to, alternate back and forth from there. I can move in both directions. So then where we're negative, we are concave down. Which is why I have that answer. Okay. All right. So yes, we will finish up T5L3. Again, it won't take very long to finish up T5L3 tomorrow because you're going to get almost all of those written down today in class. And then test 5 lesson 4, which is what we will do on on Tuesday after we finish out those notes and just verify those notes being correct is just some AP style questions. Wednesday is your review day, and your test is on Thursday with tutoring Wednesday afternoon. Okay? All right, I will see you all tomorrow. Make sure you do Test 5 Lesson 2's worksheet and Test 5 Lesson 3 note flip for me to be prepared for class tomorrow. All right, by the way, also congratulations to Andy on tennis states this past Friday. We are very proud of you. And also congrats to our band for your competition Saturday. And good luck to soccer tonight. I think it's tonight. In the next round of playoffs. Yeah, I think that's that. And just because, I always have to say something about Harper. My phone's dead, so I can't even show you. Harper kicked he kicked 4 field goals Saturday, and 2 of them were good. The first 2 were good. He did miss the last 2, but his first 2 were really good. I'll have to show you that video when I come back. But nonetheless, make sure you get done what needs to get done, and I will see you all tomorrow.